Alright, in this video, we're going to look at slope-intercept form applications. So we're going to apply slope-intercept. So make sure you put today's date in the top right-hand corner. So just a reminder that slope-intercept, remember, is y equals mx plus b. And m is the slope, and b is the y-intercept. So we used that to graph equations before, and now we're going to start applying that to some word problems. So some important pieces to consider. So remember, m is your rate of change. Another word for the y-intercept is the initial value. And then two other pieces a part of that equation. X refers to the independent variable, which means that whatever is happening with x does not depend or rely on another piece of the equation. And then y is the dependent variable, which is the opposite definition, which means it does rely on the other variable in the equation. So what we're going to look at is some word problems where we have to identify the independent and dependent variables and then break down the rate of change and initial value to create an equation. And then later we'll learn how to use that information to solve parts of equations. All right, so let's look at an example. Let's say a cell phone repair store charges a $25 fee plus $10 per hour to fix a phone. So we have a cell phone repair store that charges a $25 fee plus $10 per hour to fix a phone. We're going to write an equation to represent the total costs to fix that cell phone. So I'm going to highlight some key pieces here. The first part is this $25 fee. So just even to bring in the phone and have them look at it, they're going to charge you $25. And then on top of that, they're going to also charge you $10 per hour. So that word per is really important. I'm going to circle and highlight it. Anytime you see that word per, that means you're multiplying. So when you think back to our formula with y equals mx plus b, the only variable that's being multiplied with something is x, because that's being multiplied by the slope. And here, this is telling us our independent and dependent values. Our independent value is hours, because time is independent, it doesn't depend on anything else. And then our dependent is the cost of charging or getting our phone fixed. So if we were identifying the x value, or what x means, here it's the total number of hours. and then y is the total cost. In this problem, the rate of change, or the slope, is the $10 per hour. You can also see that we're comparing two values, which is what slope does. It compares two things. And the initial value is how much money it costs initially to even get the phone looked at. So breaking this down, I can write an equation where y equals the slope, $10 times x plus 25. This equation represents this situation, and now I can use this equation to help solve any problems that might come up with that problem. So we had to find the dependent and independent variables, and then we had to find the slope and the initial value from the equation, for the equation from the problem. Keywords to look for a slope are per or each, and then keywords for the initial value are like a one-time fee or something that only happens once, or what you start off with, your starting value. Okay, let's look at another example. All right, let's say for example 2 that Cooper bought season tickets to the Bears. It costs $50 per game plus a $10 shipping fee. Let's write an equation to model the total cost for going to the Bears games for Cooper. And we're going to identify our variables. So again, I'm going to highlight the important information. So there's the $50 per game. And there's this $10 shipping fee. And anytime I see that word per or each, that's going to highlight which one is the variable that I'm multiplying with. So that $50, I'm going to multiply it with the variable x. So in this case, x represents the number of games. Remember, the hashtag sign is a symbol for number. Y is the total cost of attending those games. M is $50 per game. And B, your initial value, is how much it costs to ship. So that's $10. So the equation I can write for this is y equals 50x plus 10. Because I'm doing $50 times the number of games plus the $10 I have to pay to ship the tickets. Let's look at one more example. Okay, let's say Andrew buys a car with 25,000 miles on it. He typically drives 12,000 miles each year. So let's highlight our important information from that problem. We have the 25,000 miles that he starts off with when he purchases the car. And then he drives 12,000 miles each year. And here that keyword is each. So anytime you see each or per, that's telling that you're multiplying by something. So in this case, X, our independent value, is the number of years that Andrew owns the car. And Y is the total number of miles. So the total miles on the car. So my slope, that's the one that goes with each or per. So that's 12,000 miles per each year. And my initial value is how many miles were on the car when Andrew purchased it, which is 25,000. So I can write my equation, y equals 12,000 miles per year, 12,000 times x, plus 25,000 that I initially started with. So that's how we can apply the slope-intercept form to some word problems. We're going to get some practice with just setting up the equations, and then a little later we're going to work on actually using the equations to solve problems given information related to the problem. So you should be able to work on the next practice activity for these.